The STL is a lot less big than most people think. Today we will have a look at all the components of the standard template library. Let's get an overview about the complete structure. Hi everyone, I decided to explain the complete STL. We start from the ground up and cover everything that's inside. Even though it is important to know how the small stuff in the STL works, the big picture helps you to understand how everything is connected together. That's why today we will cover this overview. This is just about the structure of the STL, so no code today. This is how the STL looks. You basically have four big components that are somehow connected together. So the STL includes containers, it includes iterators, it includes algorithms, and it includes a small utility part. Containers are basically where you store your information or your data. There are different kinds of containers. There are sequence containers, associative containers, and all of them behave a little bit differently. But what all containers have in common is the interface, how you would access the data. So the interface to any container is always an iterator. So you have a container to store your data in, and then you have an iterator to access whatever is inside a container. And this is where the algorithms come in. The algorithms use iterators to access containers and then do whatever they want to do with the data. So for instance, you could search something, you could replace something, you could transform something. But the important part is that the algorithms always use iterators to access the containers. So whenever you want to access something in a container or use an algorithm, you always need to use an iterator. The iterators themselves come in different powers basically. So there are always 6 different levels of iterators, and each iterator is able to do a little bit more than the iterator before that. So it starts with a very basic forward iterator, and then the top or the best iterator that can basically do anything is then the iterator for random access and continuous memory. But you don't really need to care about that, because the container and the algorithm, they basically define what kind of iterator you need. This means that if you have a specific container, this specific container will just support a specific iterator. So for instance, if you have a standard array which is continuous in memory and has fixed addresses, the iterator that is supported is automatically also the iterator which supports random access and also continuous memory, and you can then use any algorithm that would work on that kind of iterator. So the important info here is that whatever your container is, it will support a certain iterator, and algorithms will need a certain iterator to perform. So for instance, if you want just to find something, standard find, you need a very low level iterator, whereas if you want, for instance, to reverse the order of your container, then you need a little bit more powerful iterator. But overall, there are 6 different levels. Containers themselves also come in 2 different flavors. You have sequenced containers and associative containers. So sequenced containers is something that is always sequential in memory. So it's like one thing comes after the other, comes after the other. So how they can be stored is a little bit different, but it's basically that you have a sequence of objects in your memory somewhere. And associative is a little bit different. So associative usually means that the container itself is always in a certain state, like it's always sorted, or it's some sort of a map where you have a key and an index. So these are more or less special use, and there are not very much variants. If you have a specific use case, you will need a specific container, whereas the sequenced containers, there you have a lot more options to choose from, really depending on how your data looks like. The 4th part of the STL is what is generally called utility. It's just some additional functionalities that the STL offers to ease access, something like functors or something like standard pair, or just these let's say quality of life features that make using all of this a little bit more easier. So yeah, that's already it. If you understood how containers, algorithms, and iterators work together, you're basically already half through the structure of the STL. This is the basic concept that everything is built around, and if you understood that, then you're already a great step ahead and can get into development much faster. If you enjoyed the content and want to learn more about the STL, then probably this video here is for you. Or if you want to subscribe and get started, press the button below. Thanks, and as always, enjoy coding.